So we're going to do the vocabulary for this unit. We're going to start off at the very top here. And these should be words that you've learned in the past. So a variable, having a hard time here, is a letter or symbol used to represent an unspecified number or value. Okay, an algebraic expression is an expression that contains at least one variable. Okay, a term of an expression is a number, a variable, or a product or a quotient of a number and variable. Now I'm going to say there has to be a plus or a minus sign in between terms. So this could be a term, this could be a term, this could be a term, that could be a term. If I have 3x plus 4, 3x is a term and 4 is a term. Those are two totally different terms. A variable term is a term that contains a variable. A constant term is a term that does not contain a variable. Coefficient is the number in front of the variable. When writing an expression to represent a situation, choose a variable to blank each unknown to represent each unknown value in the problem. Tells what the variable means. So let x equal number of apples. Inverse is the opposite operation. Addition will get 0, multiplication will get 1. Reciprocal is when you flip the numerator and denominator of a fraction, not a mixed number. So if I have 4/5, its reciprocal is 5/4. Like terms are terms that have the same variables with corresponding variables having the same exponent. So 4 and 3, those would be like terms. 4x, 8x would be like terms. They have the same variable with the same exponent. Simplest form is an expression that when it is replaced by an equivalent expression having no like terms or parentheses. So all I did was take this, I combined the like terms by adding the coefficients and placing the x. Equivalent expressions represent the same value for any value of the variable. So I take these two and I add them together. Sometimes you can think of it as this too. Equivalent expressions. So 5, 6, these two are equal to each other. They're the exact same thing. Absolute value is the distance from 0. Power The power is used to refer to the expression, the value, or the exponent of the expression. So if I have 4 to the third power, this whole thing right here is considered a power. In the power, the base is the number being multiplied by itself. So 4 times 4 times 4, it's this number that's down here below. The exponent indicates the number of times, there we go. A number is being multiplied, so it would have been that number right there. Okay, counting numbers, 1, 2, 3, 4, blah, 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 forever and ever. Then whole numbers. Whole numbers, the only difference between counting and whole is whole numbers have 0. Integers are whole numbers and they're opposite, so it has the negative numbers. Notice there are no fractions and no decimals. Rational numbers are when you bring in the fractions and the decimals. Numbers that can be written as a fraction. Okay, so addition, add, sum, greater than, ooh, that was weird. Subtraction, difference, subtract, and there are other words too. These are less than, multiplication, product, times, twice is the same thing as saying 2 times, division, quotient, divide, oops, okay? So now the properties. So the reflexive property for any quantity is equal to itself. So if you have 4 equals 4, that's the reflexive property. If you have 5a equals 5a, that's the reflexive property. Symmetric property, if one quantity equals a second quantity and the second quantity equals the first quantity. So if 4 equals 4 and 4 equals 4, just kidding, I don't want to do that. 4 equals a and a equals 4, all you've done is switch it around. That's the symmetric property. Now transitive is if one quantity equals a second quantity. So if a equals b, these two are the same, you see that? And b equals c, then a equals c. So what they've done is they've taken these two, and by the transitive property, they are equal to each other. Substitution, a quantity may be substituted for its equal in any expression. So if I said x equals 4, and I add 3x plus 2, I would replace the x with 4, and that is called substitution property. Additive identity. Additive would be 0. When you add by this number, you get the same number. So 4 plus 0 equals 4. For any real additive identity property, for any real number, the sum of a and 0 is 8. So basically it's this. I did the additive identity property for you. Okay, additive inverse is when you add the opposites together. Okay, inverse is always opposite. A real number and its opposite are additive inverses. So if I took -3 and I added 3 to it, it would get 0. These are opposites of each other. The multiplicative identity is the number 1. When you multiply this number, you get the same number. So 4 times 1 equals 4. So anytime you multiply by 1, you're going to get that same number. So this is product. Inverse. Multiplicative inverse. This is the reciprocal of a number. So if I have 4/5, the reciprocal of that is 5/4. The multiplicative inverse says when I multiply these two numbers together, when I multiply the multiplicative inverses together, I will get 1 as my answer. Multiplication property of 0 is anytime you multiply by 0, you get 0. So 3 times 0 equals 0. I could have, but immediately as it has this 0, the whole thing becomes 0. Okay, the associative property. The associative property says the way you group 3 or more numbers when adding or multiplying does not change their sum or product. So if I have 4 plus 8, in parentheses plus 3, that's the same as taking 4 plus and then 8 plus, oh, that was weird, 8 plus, oh, seriously, plus 3. Okay, if I have 4 times 3 times 15, that's the same as 4 times 3 times 15. They're the exact same thing. The commutative property means in order in which you add or multiply numbers does not change the sum or product. So 16 times 3 is the same as 3 times 16. Or 7 plus 5 is the same thing as 5 plus 7. Distributive property. 4, when you multiply a number by a sum, this is by a sum, that should also be difference. So x minus 3, so 4x minus 12. Closure, this is a little bit weird. When you are doing an operation, add, subtract, multiply, or divide with a certain group of numbers, the answer to the operation is in the same group of numbers. So if I had whole numbers, okay, and I added a whole number, they can equal a whole number. If I subtracted them, okay, that doesn't mean it's going to be a whole number, because if I had 4 minus 8, that would get me -4, and that's an integer. So subtraction wouldn't work. If I took 4 times 4, that would get me 16. So as long as you multiplied, so this, it is closed under multiplication. Okay? Then order of operations. We're changing it from PEMDAS to grouping symbols because in algebra you'll be using parentheses, braces, brackets, absolute value, and fraction bar. But then exponents, and then left to right multiplication or division, addition and subtraction as you go left to right.